Alright, morning year 11s. Um, we continue with functions, and the last chapter we're gonna look at are transformations. With 7a, we're gonna look at that particular one which is called a translation. So first, a little bit of a review is Cartesian plane is represented by a set of r square means it's two real numbers, so it's an ordered pairs of real numbers. This is how you will define your set with the rule for r squared, and later on when you define a function, you'll see that you might have a variation of the rule, whatever functions we studied before, parabola, square root, and so on. What we're going to look at is our transformation. So for each ordered pair, it will be matched with another unique ordered pair. Unique means it's only one matching pair, and we're going to look at examples of transformations of the plane. So the first one, let's say we translate 3 units in a positive direction of the x-axis. What it means is for each ordered pair x and y, so from that set it will be a list of values, or it could be a rule. The new ordered pair for the x value, which is going to transform it into x plus 3, and again each point in the plane is mapped to a unique second point, or a pair of real numbers. And in addition, every point in the plane is an image of another point under this translation. So you map from one point to another, and vice versa. The point that you get is also the image from the original point. Using the same transformation, so here is the way you will write it as a mapping. So you have your original coordinates, your image coordinates, and the arrow indicates that you have a transformation, and the whole altogether it will show the mapping. We do that with a particular point. We evaluate the answer graphically. That makes sense that you shift to the right. In red, the points are the original points, and in blue you have the image point resulting from the mapping and that translation to the right. As you do the mapping, the convention is for the image point you will use the coordinates x dash y dash, and as they are transformed you can write the relation for the plus 3 to the for the translation to the right, but also we need to write the mapping when there's no transformation. So the y dash is matching the original y. So to summarize, if you have a translation of h unit to the along the x-axis in a positive direction, you will do plus h. If it's a k positive in the y direction, so you add plus k to the y coordinate, and we can also rewrite those as mapped relationships or equations. If the h and k were negative, so for h you will move in the negative direction of the x-axis, and k will be in the negative direction of the y-axis, you will substitute with minus h and minus k, and similarly in the equations. You probably can combine those two together. Just be mindful when h and k have different signs, meaning if they are positive or negative, you will need to adjust the plus and minus respectively. Now, just to keep that in mind for the graphing, just taking a step back, if you have two image points that are matching, that are the same, it means the original points are also the same. That's coming from the fact that a point is uniquely mapped through those translations. So if you have a translation that is h and k, it means for any point AB that has been transformed by and being the image, it needs to match the x plus h and y plus k. That pk is by doing that point AB, by minusing, by doing the inverse operation. It'll probably make more sense if using the equation, and I'll do that next. So we have our transformation. What's important with here when we have the minus h and minus k is if we replace x and y by the opposite operation, we can substitute that into the rule to get the graphing of the image function or the transform function. So let's get to that. So here the set of point is a rule which is a y equals x squared. So it's a parabola which is graphed in red. Which is going through the origin. The transformation we're going to look at is a dual translation, 2 to the right and 4 units upwards. We can also write the mapping equations. It means for each point, so let's say we took they do that for a few points, but we look at the origin, 0 0 will be mapped to 2 4. If we rearrange this to make x and y the subject, we do the inverse operation, so it becomes minus 2 and minus 4, and then we can substitute that into our original rule, which ends up giving us this rule, and that is the rule of the image functions. Therefore, we started with y equals x squared, and the new rule is y prime minus 4 equals bracket x prime minus 2 squared. So again, by doing a translation of 2 units to the right, 4 units upwards, it'll become a minus 2 and a minus 4 in the new rule. So keeping that in mind, let's say for example we have a function that is, it's an image function, has been transformed, but that minus 2, we just substitute x minus 2, and indicates that we translate 2 units into the positive direction. Another way you could do that is x prime hang on, this is my x prime minus 2 because this is our image, and that needs to be equal to x, and when we rearrange that to be x prime, that gives us our mapping equation. And because it's a plus 2, it is a translation of 2 units in the positive direction of the x-axis. And then we can do the same for various functions as well. Alright, and that's it for 7a, and I'll see you on the next video for 7b for other transformations.